And let's continue to find the absolute value of complex numbers, starting with 4 minus 2i. And as I mentioned in the previous video, the absolute value of the imaginary number is just going to be the distance from the origin of the imaginary real plane to the point, represented by number. So 4 minus 2i, where is that going to be? So 4 to the right here, and 2 units down, because it's negative 2i. So go down here. Okay. So now we just want to calculate this distance here, and that will be the absolute value. Of course, we're going to use Pythagoras and this triangle here, right? So that's a distance of 2, that's a distance of 4. I can call this x. So x squared is just going to be 4 squared plus 2 squared. So x will be the root of 16 plus 4, therefore just the root of 20. I can simplify this a little further, right? Because 20 is just 4 times 5, and the root of 4 is 2. So 2 root 5. And that's the absolute value. Whoops. Of that complex number right there. What about the absolute value of 3 minus 3i? Where's that going to be? So 3 units this way, and 3 units down. Now this is going to be messy, because I have things on the way. Okay. So now we're talking about this triangle, and the lengths are, let me pick a different color, completely different color, the blue. It's a nice dark blue to calculate. That's no longer x, I'm just going to call this y instead. Just picking letters at random. It's 3 units long and 3 units long also. So what is the absolute value? Just the distance between the origin to the point. That will be y squared equals 3 squared plus 3 squared. Y will be the root of 9 plus 9. So y is the root of 18. And I can simplify this because that's root 9 times root 2, which simplifies into 3 root 2. So that is the absolute value of this complex number. And that's it. We're done.